Hello, and thanks for watching this video presented by Nuvation Energy today. This presentation was done at PlugVolt seminar in July 2023, and the topic is on energy storage designs that maximizes supply chain flexibility. So I'm your presenter, Joe O'Connor. I'm the Director of Energy Storage Solutions at Nuvation Energy. I got my start working in a solar company about 15 years ago. I've been working in solar and batteries ever since. I actually published a book, Off-Grid Solar, back in 2016, and still selling on Amazon today. So now I want to tell you a bit about Nuvation Energy. So Nuvation we got our start about 25 years ago. We began focusing on electronic product design. But about 15 years ago, we started to focus in a bit more on the energy industry. We designed our first BMS back in 2008. We have two offices, one office in Ontario, Canada, and another office in Silicon Valley, California. So what do we do? Nuvation, first and foremost, we manufacture and sell battery management systems, as well as energy management systems. So we are a product supplier for many developers of energy storage systems, but often those customers of ours also hire us to do engineering design services for them. So what that usually looks like is we help them with design decisions and integration decisions. We do BMS variants for them, and we help ensure that their new design is the best that it can be based on the experience that we have from working in the industry. So we have many customers all around the world, mostly focused on North America because that's where offices are, but definitely have a big presence in Europe and other parts of the world. Okay, so today I wanted to talk about supply chain flexibility. And really, the supply chain for energy storage systems is really evolving, and it's changed a lot in the last many years, and we expect it to continue to change as the industry grows. So one thing that we've all noticed is that lead times and costs are very unpredictable now more than ever. The COVID pandemic really mixed things up for supply chain and pricing and availability and lead times. We've seen that supply and demand has been pretty erratic of what is needed and what's available, and this has had a huge effect on the prices for raw materials. And the industry is just growing, so manufacturing growth is huge in different parts of the world. So the supply is going to be increasing with those new manufacturing plants. So we've also noticed that battery technology itself has been changing pretty frequently. In the early days of doing energy storage systems, we mostly saw lithium chemistries that were focused more on nickel and cobalt. NMC is a very common one. But in the last many years, we've noticed that lithium iron phosphate has become much more popular due to its benefits for safety. But we're also noticing a lot of new chemistries come up that seem very promising. So what's next? Maybe zinc or sodium ion or something else might be the future of energy storage. As far as cooling systems go, we've, in the early days also saw mostly air-cooled systems, where today we're seeing liquid-cooled be a much more common technology, a little bit more complicated at times, but has some increased benefits with liquid-cooled. Fire safety systems has evolved a lot. In the early days, it was pretty much about fire suppression systems and stopping fires if they were to start. Later, the industry shifted into a focus more on stopping it from propagating. So if you could have it stop at the cell or module level and not expand, that was very important. But today we're seeing a lot of focus on preventing the chance for explosions. So even if there is a fire, there's some off-gassing, and we need to stop any chance of an explosion. So our question is, what's next? What's going to change over the next 2, 3, 5, 10 years, and how is industry going to evolve and match for that? So let's take a moment just to look at the lithium battery market and kind of what's changing and what's growing. So China is really dominating in the manufacturing of the cells and for energy storage systems and EVs. But the US and Europe are starting to catch up. It looks like China will continue to be a dominant player, um, uh, providing the majority of the cells to the market. But North America and Europe are definitely going to be growing with their percentage related to China. And the growth in general is orders of magnitude of growth over the next decade or so. So just looking in at the US market and where the growth is happening, it's pretty incredible to see that, where we are today of just about 60 gigawatt hours. And we're going to grow into providing something like a terawatt hour of battery capacity of manufacturing within the US. So it's really incredible to see the manufacturing market growing like that. So what do we know about sourcing lithium cells? We know it's evolving, we know it's changing, and we're pretty sure that where you're sourcing components today is not where you're going to be sourcing them in 5 to 10 years, or at least the product types will be changing as well. And as the industry grows, the supply chain is going to grow and change too. So we're pretty certain that the supply chain is going to be very unpredictable in the future. So that gets us to the point of the topic for today. So we incorporate a supply chain agnostic design, basically supply chain flexibility design. And this is something that Nuvation uses, but first let's understand what it is. So there's kind of, this is a whole spectrum here. And if you were to go all the way on one side, you might have a specification controlled design. And on the other side, you'd have a source controlled design. So let's kind of break that down and try to understand what it is. They're kind of on the two extremes. So let's start with an example. So a specification controlled design would be something like saying, I want an EV that has 250-mile range and has a great sound system. A source controlled design in that same example would be, I want a Tesla. In the end, you're still maybe getting that EV with 250-mile range and a great sound system, but you might be forgetting all the other manufacturers that are out there that might provide a vehicle that meets those requirements. So when you're doing specification controlled design, your requirements are based on the specifications and not the manufacturer. That's really important because you're not isolating yourself from other options and availabilities. So if you design this way, it'll make it much easier to swap major components in the future. And you can swap them for a number of reasons. What's just available? What can you get with a good lead time? Maybe a certain company is not as dependable as they used to be, and you need to find a new supplier. Or maybe the features and capabilities aren't there for a certain subsystem that you're working with. Or maybe it has too many features and you want something cheaper. So the goal here is to really find the best price for the expected performance. Nothing more and nothing less than what you need. Okay, so that's on one end of the spectrum. Let's look at the other side. So if we're source controlled, the requirements are based on the specific manufacturer regardless of the alternatives. And we don't do this on purpose, but it just happens this way when we do design. We'll say we need to use this particular provider because they provide what we need. And the problem with this is designing by the source means that the If the supplier changes, you probably have a complete redesign. If you decide to change the cells in your energy storage system, you're probably going to have to start from scratch and design a brand new system. Also, historically with energy storage projects, if you swap battery cells or the module or something else, it requires a recertification with UL and other certifications like that. So it's pretty challenging to swap out components when you're source control designed. Okay, so let's go to a very simple example for specification controlled. Great example I like to use is if you're building a deck and you want to buy lumber. You're going to the hardware store and you're looking for that lumber to build your deck. The funny thing is, who made the lumber? Like, does anyone really care? No, like you don't care and you don't need to know. But what is important is that it meets your project requirements. It's 2x4s, 2x6s, it's this type of wood, it's treated for outdoors, and it meets the certifications and requirements of what you need. Okay, so now let's look at how specification control can manage risk in your project. There's lots of risks with lead times, equipment cost, and component reliability. So for energy storage design specifically, in the early days, there weren't many options. You pretty much had to buy a full turnkey AC energy storage system. It includes all the components. It was energy storage systems are very complicated. In the early days, the best way to sell systems was to sell a complete turnkey system. But not that long ago, some developers got wise and said, hey, the most complicated part is this energy storage block, the DC block. What if we just buy that turnkey system from the suppliers that we can find? And then we could make our own EMS or work with a third-party EMS company and then choose a different power electronics, a different inverter based on what our requirements are. This gave a little bit more flexibility in what developers could do on projects. And maybe you'd switch an inverter for one project to the next, or maybe you switch the EMS partner that you work with who has the right features that you need. Well, to continue with this trend, what we're doing today with our customers is we're turning the entire energy storage system into specification controlled. So what this looks like is the enclosure and all the subsystems are typically coming from one contract manufacturer who can do the fabrication and assembly. And we're buying the cells or maybe modules from a number of different cell and module providers. And then using our third-party BMS, we're able to configure for those different cells. And then using an EMS and a PCS on top of that. So really, this specialization is really only possible because the industry is growing, the industry is maturing, there's enough space for different companies to focus on different areas, such as us focusing on BMS technology. And this really helps with mitigating risk. Also, today developers are expecting more design control over their ESS. They don't want to just take whatever an ESS supplier offers them. They want it to be tuned for their project and meet specifically their requirements. The other benefit for developers is when you disaggregate all of these components, it gives you the chance to have greater margin capture. So rather than paying for the margin of a turnkey system, why don't you take that work in-house and make that profit yourself? And what's interesting is this, while this may be hard or different from what we've done in the past for the energy storage industry, A lot of other industries have already gone this way and they've been this way for a while. So I'm going to give an example of how solar photovoltaic projects already are specification controlled, and the automotive industry is also that same way. Okay, so why is this important? Why is it so important to disaggregate these systems and buy them separately? It sounds like it's more complicated, so why would you want to do it? Well, if we look at the cost breakdown of what an energy storage system is composed of, the majority of it is actually the cells. And this isn't, the modules or the packs. This is just the cells. The LFP cells in this energy storage system are over 40% of the total cost of this BESS. It's pretty incredible how expensive and how large of a portion just the cells are. So instead of sourcing from one cell supplier for your system, what if you could source from 3 or 5 or 10? That's really the advantage that comes from the specification control design. Also, the main reason why cells are expensive is because the volatility in the lithium carbonate pricing. If we just look at the last 5 years or so, you can see that there's a 15x increase in just 2 years. From 2020 to 2022, lithium went up by 15 times. It's come down quite a bit, but this makes it really hard for cell providers to have a fair price, an even price. So everyone has different prices based on how they source their materials. So the goal here is really to reach reliable supply chain, reliable price, reliable schedule, and if you have more options, that reliability comes with it. Okay, so the LFP cells, we keep on focusing on this aspect. What's changed? So previously, 5-10 years ago, there were a lot of different cell chemistries. They came in different formats, cylindrical, pouch, prismatic. There are different capacities, different capabilities. So it was actually really hard to swap out cells because between different cell providers, it just didn't fit in the box. So it was really hard. But what we've noticed is that a lot of cell providers in China and elsewhere are focusing in on this typical 280 amp hour LFP prismatic cell. The dimensions are very close in size. The cell terminals are also, dimensions are very similar. And the industry seems to be following this trend. They're not identical, but they're very close. And we've found now over 10 cell suppliers with very similar dimensions and specifications above. Some are lower priced, some have better performance, some are from tier 1 suppliers, some are from tier 2. And really what you want is you want these options. And there are scenarios where maybe you do want a tier 2 supplier at a lower price because that's the only way you're going to win a project. Maybe it's a good enough approach rather than getting always the best cells available. So this is really important as supply chain changes. So we've mostly been buying our cells from China, but we're going to start seeing more options from the US and from Europe. So if you're selling projects into the US, maybe you buy cells from the US. If you're selling projects into Asia, maybe you buy cells from China. So it's best to be able to design a system that can work with a number of different cells. And they're not identical, but they're very close. And the only way to do this is with a third-party BMS, and the Nuvation BMS allows you to do this. And really what we're doing is we're allowing developers to commodify the battery cells, which represent over 40% of the cost of the energy storage system, and reduce the cost of switching cell providers. In the past, you probably could switch cells, but it was very expensive. We're bringing the cost of switching way down. So here's an example of our BMS and having different cells that go into a module. Okay, so I mentioned earlier that other industries already are structured this way in their design process. I spent a lot of my career working in the solar industry, and this is just the way it always was. So it was always specification controlled. And what this really means is a lot of the solar equipment, it just follows the industry standards for module dimensions and the way that you mount the modules, how to electrically connect them, what the connector types are, what the voltage and current requirements are. Um, and so you could purchase these components separately, and you could win a project, and you could quote on a project with a certain price. And then 6 months, 9 months later, you say, hey, those solar cells aren't available anymore at that price, but these other ones that are higher wattage are available, and you can switch to those and maybe improve the cost of your project because you're able to switch later on. The energy storage industry doesn't work this way. If you quote with energy storage supplier, you pretty much have to stick with it. Otherwise, it's a huge design rechange to switch providers. Yeah, so as I said, solar PV strings, they need to electrically meet the requirements of the inverter. It doesn't matter what solar panel it is. You put them in series and parallel in such a way that complies with that inverter, and that's all you need to do. There's no proprietary technology required when you hook solar panels up to an inverter. So let's see how this has typically gone with energy storage projects. It's historically been source controlled, although there are examples of this changing. But it usually means that there's a specific battery manufacturer that is selected for a project, and it's designed onto that site. Maybe it's in a 20-foot container or some proprietary enclosure. And if that energy storage supplier changes, then you have a complete redesign to that site. The entire site needs to be redesigned for this new provider. Some of the providers might be similar, but they're not identical. And even if you wanted to swap out a subsystem, like let's say you wanted to work with a particular provider and you wanted to switch from NMC to LFP cells, well, that's just going to be very challenging, and then you're going to have to recertify and work with UL all over again, and your project is now delayed another 12 to 24 months. So this whole specification control design is made possible by our BMS or any third-party BMS. The Nuvation BMS is highly configurable, so it allows you to use different cell chemistries and different cell types. If there's different requirements from different providers, we're able to configure our BMS to work with them. It uses the same hardware, so there's no hardware change, it's just a software configuration change. That's something we can do, or our customers can also reconfigure it themselves. And this is important because all the higher level system sees is a Nuvation BMS. It doesn't know what's underneath it. So we can abstract the whole layer below of what the batteries are doing and also meet safety. So the Nuvation BMS is UL recognized. So what that means is that for every new system that needs to get UL certification, a lot of the tests are already done and complete. So, and typically what that looks like is what normally would have taken a certain number of time and have a certain amount of cost, we can break that down to about 1/3 of the time and 1/3 of the cost because all of the BMS certifications are complete. So also certifying a number of different cells, you can do them all at the same time within the same system. Okay, so in conclusion, where are we at? So we can see that the industry is growing and it's changing. And because of this growth, that now specialization is possible. So we're able to pick and choose all these different components because the companies like Nuvation exist out there that can focus particularly on one component of the energy storage system. In our example, you can buy just our BMS. So we've seen that it's beneficial to follow specification controlled design as opposed to source controlled design. And this allows for more flexibility in your supply chain and it results in lower risk to the project, better pricing, and much better schedule as well. So what's interesting is 10 years ago, back when we started, and before that, this wasn't an option. So this has all come about in the last couple years where this has now become a possibility to pick and choose these components. So what we're seeing is most developers are now designing with this method in mind, and it does make sense because this is the way the automotive and solar industry is already working. Okay, thank you for watching the video today. We appreciate your time and spending time with Nuvation Energy. If you have any more questions, you'd like to learn more about Nuvation Energy, please visit our website. If you have any questions for me, my email is on the screen. And thank you for your time today.